Welcome to qnawire.
Okay, so we are going to find the intervals on which f is increasing and decreasing, the local max and min, the concavity and inflection point of f of x. So in order to find the intervals on which f is increasing and decreasing, we have to apply the first derivative test, which means finding the derivative. So in this case, we'll apply the chain rule to both e to the 2x and e to the negative x. So we take the derivative of 2x, which is just 2, and then we take the derivative of e to the x and keep 2x. I'm going to rewrite this. And then you take the derivative of negative x, which will be negative 1. And then we let e to negative x. And then we set this function equal to 0, but we're going to actually simplify this further. I'm going to rewrite the same exact thing so you can see what I'm doing. I'm going to pull out an e to the negative x. So I'm going to pull out e to the negative x. And then I'm going to put, remember that if I'm going to pull out an e to the negative x, I'm going to rewrite this, e to the negative x. I need to be careful with our exponent rule here. I actually have to add an extra 2e to the 2x, because if I write it as 2e to the 3x over e to the x, 1ex cancel and it makes 2x. So I have to write 2e to the 3x minus 1, and set this equal to 0, not 6, 0. And then e to the negative x has no real solution, so we ignore that. And now we let 2e to the 3x minus 1 equals 0. So you add 1 on both sides and divide by 2. You get e to the 3x equals 1/2. Now we take the natural log on both sides. And then this gives us 3x equals natural log of 1/2. And then we divide it by 3. So we get natural log of 1/2 divided by 3. So now we are going to apply our sign chart to this. We are only going to consider the entire function f prime, and we're only evaluating it at one point, which is a very weird point. So it's ln of 1/2 over 3. I'm going to put that over, bring a line here, and if you actually plug it into you plug in a very big negative number into f prime, which is right here, you get a negative number, and if you plug a very positive number, you get a positive number. So since now we know the signs of f prime, we know that it's decreasing on negative infinity to ln 1/2 third, and then increasing on ln 1/2 1/3 to positive infinity. And then since this is a function that is decreasing and then increasing, we know that the local min occurs at x equals ln 1/3 and 1/2 1/3, and there's no local max. And now we are going to be finding the concavity and inflection point. So we take the second derivative and we apply our chain rule again. And if we apply our chain rule again, we get 4e to the 2x plus e to the negative x. And now if you try to set this equal to 0, you'll realize that one thing, before we even set it equal to 0, we have to realize that this function, the exponential function, it is, they are all, you'll realize that this function f double prime, is actually positive. It is all positive. So you plug in any number of x. If you plug in a very negative number, you still get a positive number. And if you plug in a negative number, you get a positive e to the negative x. And this is still a positive number because it's an exponent function. So all values of x gives it positive. So that means that since it is always positive, so always positive, we know it is concave up. So negative, it was concave up from negative infinity to infinity. So concave up. And since there's no sign no sign change occurring in our concavity, we know that there is no inflection point. So just a side note, when you're working with exponent function, you always want to look for slight clues, like if it is positive on all of its interval, because it makes it a lot easier to evaluate. You can just skip the whole process of letting it equal 0. So just a side note, when you're looking at exponential function, think more critically about the values of x and what sign they are. And that is it.